Hello everyone, my name is Shreya. Welcome to my YouTube channel. Today I will discuss different examples of convergent sequences. If you haven't watched my previous video, please make sure you check it out because I discussed the definition of convergence more thoroughly in that. I will leave the link in the description of this video. Okay, so let's get started. We will do a quick recap of the definition. So, for all epsilon greater than 0, there exists some natural number n such that for all n greater than or equal to n, my sequence a sub n minus its limit L, and the absolute value of that will be less than epsilon. Okay, so now let's go over some examples of convergent sequences. One example is a sub n is equal to 1 over n. Now, if you remember, this is also a monotone decreasing sequence, like in the previous video. That means that for each successive step, the elements in my sequence get smaller and smaller. We have defined some preliminary epsilon neighborhood for this sequence. I will let this be epsilon. So this is L plus epsilon, and this is L minus epsilon. Now I can define some value n right here. We will let this be n. As you can see, for every value in this sequence after n, it falls within this neighborhood. Now let's look at a different epsilon neighborhood for the same sequence. As you can see right here, for the same sequence, we have a slightly larger epsilon neighborhood, so I will have to shift back my value for n. So I'll let this be L plus epsilon a, and I will let this be L minus epsilon a, and this can be n sub a. As you can see, for every single element in the sequence after n sub a, it falls within my defined neighborhood. Therefore, 1 over n is a convergent sequence, and its limit is 0. Now, let me go over another example of a convergent sequence. We have a sub n is equal to 3. Essentially, what that means is every single element in the sequence is just 3. Therefore, the limit of the sequence is also 3. Here I have defined two different epsilon neighborhoods for the same sequence. So for this, let me say L plus epsilon sub b, and here I have L minus some epsilon sub b. And I can draw some n right here. So this can be n sub b. And as you can see, for every single element in the sequence after n sub b, it falls within my defined epsilon neighborhood. I can do something similar for the epsilon neighborhood down here. So I have some L plus epsilon sub c, and I have L minus epsilon sub c. Now I can maybe add an n right here, and I have n sub c. For every single element after n sub c, it falls within my defined epsilon neighborhood. Therefore, a sub n equal to 3 is a convergent sequence. I want you guys to notice one thing. There's something special with this sequence. Because it's a constant, I can kind of shift my n anywhere, and it will still meet the requirements set by the definition. So essentially, for every epsilon greater than 0, for all natural numbers n, I meet my definition. Hence, this is a convergent sequence. Now I have a different type of convergent sequence, and this is actually one of my favorite ones. It oscillates between larger and smaller values. This is a sub n is equal to -1 to the n over n. And here I have defined some epsilon neighborhood, and I can draw my n right here. So let this be L plus epsilon d, and let this be L minus epsilon d, and this can be n sub d. For all the elements in my sequence after n sub d, they fall within this epsilon neighborhood. Now, like always, let's look at a different epsilon neighborhood for the same sequence. This time we have something that's slightly smaller. So let this be L plus epsilon sub e, and let this be L minus epsilon sub e. Now I can draw my n right here, and this can be n sub e. Now, similarly, every single element after n sub e falls within this epsilon neighborhood. Hence, because for every epsilon greater than 0, we can find some n for which the requirements are met, my A sub n is a convergent sequence. Now, let's look at a non-example, so a sequence that does not converge to any particular value. So we have A sub n is equal to -1 to the n. So essentially what this sequence does is it oscillates between 1 and -1 indefinitely. So here I have defined some epsilon neighborhood, and we don't know exactly what limit it could have. I'm guessing because it oscillates between 1 and -1, we can kind of just take the average of that and let L be 0. So yeah, let's just take this limit and test it against our hypothesis using the definition of convergence. So now let me set some n right here. So this can be L plus epsilon f, and this can be L minus epsilon f, and this can be n sub f. And then for every single element in the sequence that comes after n sub f, it falls within this epsilon neighborhood. So technically, right now we are meeting the definition of convergence. Now, because the definition of convergence says that we must find some value of n for every single epsilon greater than 0, let's try a different epsilon neighborhood. So here we have found something that's slightly smaller. This is actually epsilon equal to 1/2. So this is L plus 1/2, and this is L minus 1/2. And if you notice, within this band, none of the elements of the sequence fall. So because of that, there's no n that I can choose such that for every single element in the sequence after that n, they fall within my defined epsilon neighborhood. Therefore, A sub n equal to -1 to the n does not converge. Now you might be saying, Shreya, we picked the limit to be 0. Would we still meet the definition of convergence if we picked a different limit? That's a great question. Let's try one example. So I let L be 1, and we picked the same epsilon, so let epsilon be equal to 1/2 again. So this is L plus 1/2, and this is L minus 1/2. Here, as you can see, we have some elements that fall within this epsilon neighborhood, but then again, there are some elements that don't fall, that fall outside of this epsilon neighborhood, specifically the -1s. So for any n that I pick, I will always have some elements in the sequence that fall outside of my epsilon neighborhood. Therefore, this is not a convergent sequence. A sub n equal to -1 to the n is a divergent sequence. Alright guys, that's all I have for today. Please let me know if you enjoyed. Please like, share, and subscribe if you liked the video. And please let me know if there's any other mathematical concept that you would like me to discuss. Thank you.